Okay, this is going to be some extra problems out of section 12.3, the section on using the chain rule to take derivatives. Our first example appears to be a quotient rule problem, but actually it would be simpler to work if we don't treat it as a quotient. And instead we change this into an expression by moving the denominator up into the numerator. So the way that we do that, as we've done this before, is we move the expression 8x cubed plus 7 raised to the 4th power to the numerator, which means our power now changes to be negative 4. Seem to be having focus issues here. Okay, that looks better. So here we have our transformed function. And remembering that this is simply a coefficient of that function, then it's going to act like a hitchhiker. So we're going to bring down y prime equals, this hitchhiker is going to just come down and stay negative 4 in front of that set of parentheses. Now the set of parentheses has the power negative 4 on it, so that means in order to take care of that, we are going to bring the negative 4 down in front of the entire function and treat it as a multiplier. And then we're going to reduce that power by 1. Then we have what's inside those parentheses, and that is 8x cubed plus 7. And since this is a chain rule problem where this is the outside of the function and this is the inside of the function, the inside of the function has to have its derivative added to this product now. So the derivative of 8x cubed is 8 times 4, as 3 times 8 is 24x squared. And then plus 0 for the derivative of 7. So now we've got this long expression, and you could actually probably go ahead and enter this in MyMathLab if you used all your parentheses properly, but it probably would be simpler to have to use fewer elements here. So the first thing we're going to do is we're going to take negative 4 times negative 4, which is 16, and we're going to multiply it by 24x squared. And since 16 times 24 is going to be 384, then this is all going to be 384x squared. And again, that comes from negative 4 times negative 4 times 24x squared. So then what we have left is the parentheses, and negative 4 minus 1 means the power on those parentheses now is a 5, negative 5. And what's inside the parentheses remains inside the parentheses. So this is your derivative, y prime, is equal to 384x squared times 8x cubed plus 7 raised to the negative fifth power. Here we have a different kind of an example because it says it wants us to look at the table with the following values of the functions f and g and their derivatives. So here we have various values of the function itself, various values of the derivative at those same x values. Then we have the values of the function g at those same values and the value of its derivative at those values. So it says to find the derivative of f of g of x at x equals 3. Now, at x equals 3, the value of g of x is equal to 2. So 2 is the input for f of x. So that means we'll go to the 2 and find the value of the function f of x when x is equal to 2 and find that it's equal to 4. So now what we're finding is we're finding the value of the derivative of f of x, because that's the outside function, when f of x is equal to 4. So at the value for the derivative, we're looking to find out what is the derivative at x equals 4. And the derivative at x equals 4 is negative 5. So the answer to A is negative 5. Now we're going to look at the value of the derivative of g of f of x when x is equal to 2. Which means we're first of all going to find out what is f of 2, because that's our starting point. So f of 2 means we go to 2 and find the value of the function, which is 4. So that means the input for g is 4. So then we go to the number 4 and we find the value of g. And it turns out that that's equal to 4. So since we're actually taking the derivative of g of x, that would be this line, and we're needing to take the derivative at the value 4, then the value of the derivative of g of x is 6 over 7. So that's how you follow the table. It's actually just an exercise in figuring out what the composite function is, what function is the input, what function is the output, what's the inside function, what's the outside function. this will be our, let's see, next to the last example. This example says find the equation of the tangent line to the graph of the given function at the value of x that's stated. So first of all, we need to find the equation of the tangent line. And please remember the tangent line looks like y equals mx plus b because it's a straight line. And since it's a tangent line, we can find the slope of the tangent line by finding the derivative of f of x. And once we find the slope of the tangent line, we're also going to need to know a value x, f of x, so that we'll have a point to plug in for x and y, because that's going to be the point of tangency. So let's begin by looking at our function. Our function, f of x, is a radical function. It's the square root of x squared plus 11. We don't have a way to handle radicals directly, but if we can change it to a power, since it's a square root, it will be to the 1/2 power, then we'll be able to find the formula for the derivative, which gives us the formula for the slope. So to find f prime of x, the only thing new here is the chain rule. We bring 1/2 down in front, keep what's inside the parentheses, and subtract 1 from the 1/2. Then, because this is chain rule, once again, we have an outside function and we have an inside function. We're going to take the derivative out here of the inside function, which is 2x plus 0, or just 2x. The 2x coming from x squared. And now we're going to multiply this all together. So 1/2 times 2x is just simply x. And then in the parentheses still, we have x squared plus 11. And 1/2 minus 1 is the negative 1/2 power. And then we're given that the point of tangency is x equals 5. So we need the value of the derivative at x equals 5. So that means we're going to substitute in 5. And that means we have 5 times 5 squared is 25 plus 11 to the negative 1/2 power. And 25 plus 11 would be 36. And the 5 still in front. And now it would be simplest if we go ahead and change this 36 to the negative 1/2 power by putting it back into a radical and putting it in the denominator, since this is negative. So this is going to be 5 over the square root for the 1/2 power of 36. And the square root of 36 is, of course, 6. So our derivative, f prime of 5, is equal to 5/6, which is equal to the slope of the tangent line. So at this point, we know the value of the slope. So there's the first piece of information we needed. The second piece of information that we needed was the value of the point of tangency. The point of tangency is x f of x, but x is equal to 5. So in order to get f of 5, we need to go back to the original function. And 5 squared plus 11 is, once again, 25 plus 11, which is 36. And we need to take the square root of 36, which is 6. So the y value, or the f of x value, is going to be 6. So now we have our point of tangency. We have a value of x, and we have a value of y for our tangent line. So the only thing that we need to do now for our third step is we need to find b. So the way that we'll find b is we're going to go back to y equals mx plus b, except m is 5/6 and x is 5 and y is 6, and the only thing that we don't know is the value of b. So 5 times 5 is 25 over 6, plus b is equal to 6. And that means then that b is equal to 6 minus 25 over 6. And in order to do the fraction, you can either highlight your calculator or you can do the fraction by hand. 6 is actually 36 over 6 minus 25 over 6. So that tells us that b is equal to 36 minus 25, which is 11 over 6. So now we have all the information that we need to find the equation of the tangent line. So going back one more time, since it's a line, it has the equation y equals mx plus b. We know that the slope is m equals 5/6. We know that the y-intercept b is equal to 11 over 6. So that means that the equation of our tangent line is y equals 5/6 times x plus 11 over 6. Now, if you would like, even though it's not necessary, you can change that to standard form by multiplying everything by 6. And then move the 5x to the other side by subtracting it. So this is the standard form of the equation for your tangent line. This is the slope-intercept form of the equation for your tangent line. They're both the same line. And that's the process that you'll always follow to find the equation of a tangent line at any given value of x for any kind of a function. Your first step is always going to be 1, find the derivative. because that's the slope of your tangent. Step 2 is always going to be, then once you found the derivative, find the original function value for the given value of x, so that you'll have a point x, y. And then step 3, use y equals mx plus b. And the answers from 1 and 2 to find b. And once you find b, you have your equation. Our last problem is a little bit hard to read. The print's kind of small, but we'll get through it. Problem says, suppose that the demand for a certain brand of product is given by D of P, the demand at a price P, is equal to negative P squared over 384 plus 400. And P is in dollars, and the demand is for the number of units. So the units demanded at price P, or P dollars. And it says the price in terms of the cost is 4 times the cost minus 20. And of course the price is going to be in dollars. And the cost is going to be C dollars. And what it wants us to do is to find the demand function in terms of the cost. Now, this is not actually a calculus problem. This is actually a composition of functions problem. So what they actually want us to do is, this is the function, the formula for P. And what they want us to find is D of P, except P is this formula for the cost, which means that what we're going to do in D is we're going to substitute in 4C minus 20 for P. So we put it inside parentheses and square it, put a negative sign in front of it, put a 384 underneath it, because we're going to divide it by 384, and we're going to add 400, and it's still, since this is demand, is units demanded at a cost of C dollars. And up here, rather than being C, it is at a price at P dollars price. But now the price is in terms of cost. And that really is all that they're asking. It just sounds like more than it is. And there's no need to multiply that out. That works fine the way that it is. So I hope this helps with the rest of the problems in section 12.3. And we will be talking about 12.4 the next class period.